the mega beaver moon. I'm delighted to welcome author, journalist, and astronomy editor for the Old Farmer's Almanac, Bob Berman, to the show. Bob, welcome.
Thank you, Paul. Good to be here.
Now, I understand you're actually giving a talk somewhere about this particular supermoon. So let's just start by answering that question, Bob. And I know we've been calling it a megamoon, but let's answer the question about a supermoon. What is a supermoon?
Well, the last few years, it's come to mean a moon that's unusually close to us. As the moon goes around Earth, its orbit is not round, it's a stretched out ellipse. So once a month, it's closer than at other times. And once a year, it's particularly close. And once every number of years, it gets really, wow, super close, and that's what's happening.
Now, I was asking that question about supermoon versus megamoon because we're not great fans of how that term supermoon has kind of been spread out. For example, this is the middle of 3 consecutive monthly supermoons. And I had to say that, I asked on Twitter, what's so super about in 3 consecutive nights? And that's why we've chosen here at SLU to celebrate just the largest full moon in any given year. And to differentiate that, that's why we've dubbed this the megamoon. But if this is the largest full moon for nearly 70 years, Bob, what set of circumstances have had to come together to make this?
It's a great question, and it's certainly, we have a sold-out national landmark here of people just to see it. It just shows what the excitement is. See this big empty place? This is going to be packed with people in just half an hour or so. This place is actually sold out. We have telescopes and binoculars set up for it, so it just shows the excitement over it. So what came together to produce this? Well, if the moon falls at the same time when it's coming close, if it also is going to be full, that stretches out its orbit unless it gets a little closer. But if we are near the sun at that time, and our planet Earth is at its closest point to the sun the first week of January every year, so we're only 8 weeks from that right now, then the sun gets into the scene and pulls along with the Earth on the moon's orbit. Now, it changes the very shape of the moon's orbit and lets those close approaches or perigees get even closer than they normally come. And that's why we've got the very closest one since 1948. Wow, that's very unusual.
It is, and very much worth celebrating, and I think very worthy of being called a megamoon. Now, Bob, I'm not sure if you can see it on your screen, but we've got this comparison image up between a mini or micro moon and this megamoon, because you see an awful lot of, I have to say, it tends to be astronomers on the internet saying, oh, there's nothing different about all of this, what's all the big fuss? And we're not suggesting that when you look in the sky, you will particularly notice that it's nothing to compare it to. But here are images that SLU members have taken through the SLU telescopes, comparing this mini moon when it's at its smallest and when it's at its largest. I mean, there is very definitely a big difference between the two of those, isn't there?
You're so right, Paul. If we could only have the moon at its smallest of the year, at its apogee,
and largest,
and the moon at its perigee in the sky together, then nobody would question it. But without seeing that, all we can say is tonight the moon is only 7% larger than average. So are you going to notice a 7% larger than the average full moon? Not honestly speaking, no. Everybody who goes out and looks at it will say, I don't know, I'm not sure I see anything. Nonetheless, it's not really hype when the moon is only 216,000 miles away, surface to surface, and it has not come this close. So that's a reality. Put another way, with a 100-power telescope, the moon appears only 1 moon width away from us. And Paul, you're going to really like this a lot. You know that the moon's diameter is 2,160 miles. 2160 are those digits. And you know that its distance from us, surface to surface, tonight, actually in the wee hours of Monday morning, will be only 216,000. Same digits. So in other words, tonight, the moon is exactly 100 moon widths away from us, and that's rare. Only
we can
100
always
moon widths from us.
Always rely on you, Bob, to give us that interesting fact that nobody else has ever come up with. Now, before we take a very quick break, Bob, have a look at this live image stream coming in from the Chile High Magnification Telescope. At the beginning of the show, my jaw nearly hit my lap. I mean, this is an astounding image tonight, isn't it?
It really is, because even though we have the capability of blowing up the moon to any size we want, I think what we're seeing is that even using our widest field, lowest magnification view, the moon still manages to crowd the field of view so that we can barely fit the whole thing in.
Yeah, super. Now, Bob, you're going to join me again in a few minutes' time so we can discuss whether this megamoon has an effect on tides and possibly whether there is any link to the moon's proximity and earthquakes like the one that struck New Zealand last night. So we'll see you back very, very soon.
Okay, very good.
Now, we're going to take a very quick commercial break, but first I wanted to tell you about a special broadcast we have coming up later this week. On the 16th of November, we're sitting back in our garden chairs for a night of meteor watching for the Leonid meteor shower. Join us at 8 p.m. Eastern Time, that's 1 a.m. For Western Europe. And we're going to explain there how you can photograph meteors from your own garden or backyard. And we'll even show you how we can listen to meteors as well as seeing them whiz across our skies in all of our live feeds. So as we take this look at this live image coming in from the Canary Islands Observatory, SLU's Canary Islands Observatory at the Institute of Astrophysics of the Canary Islands. How cool is that? We have got more mega beaver moon right after this break. Paul Cox, and I'm here with author, journalist, and astronomy editor for the Old Farmer's Almanac, Bob Berman. Hi, Bob.
Hi, Paul.
Now, you showed us all of those empty chairs there. I know what's happening here, Bob. They're all at home watching our show now before they all pile off down to your auditorium and fill that. Well, just before the break, I was talking about a lot of astronomers kind of getting a little bit, I think, pompous about, oh, what's the difference on these things? But I think we're proving in both of these events tonight just how important they are. You're going to be filling an auditorium full of people because of the mega moon tonight.
Yep,
and it's a way to engage people and interest
to look at this
people.
post, that's
exactly.
for sure. Yeah, 267 people I've just been told, and they're all coming here just because of the mega moon. That's right. So
exactly.
It's exciting the public, and even if people looking up at the sky are not going to see that cartoon-like huge moon filling the sky, it doesn't take away from the fact that the tides are being affected. This is an area that does get tides, and they're going to be super high and super low tomorrow, and especially the day after, because tides usually take one day to catch up to the moon. And so this really affects us. It's not just some abstraction, some conceptual astronomical thing. There really is a link between this astronomical event and our everyday lives.
And these tidal differences that we're going to see over the next couple of days, Bob, are they also influenced by the Earth-Moon system being closer to the sun around this time of year, or does that not have any impact?
Oh, it really does. I mean, the greatest influence is always the lineup of the sun, the moon, and the earth in a straight line, or syzygy. That's what causes the sprints. It must have something to do with this. If the moon is closer to us, even though tidal effects fall off inversely with the square of distance, gravity falls off inversely with the square of distance, but tides vary with the cube of distance. So when you get a closer moon, it's the cube of its distance that affects the tidal pull, and that means it's a huge effect on us.
Right. Now, there have been suggestions, and I have to say, you often see these on conspiracy websites, but that there was a paper that came out earlier on this year from I think it was the Paris University, which is linking these close moons, these close full moons, with earthquakes. And of course, we've seen a huge earthquake hit New Zealand just last night. Is the jury still out on this, Bob, or are there any links between these moon events and earthquakes? Because kind of logically it feels right, doesn't it?
It does feel right. Actual studies have shown that the tidal effect on Earth is enough to bulge the solid Earth. It's not just the oceans that move an average of 3 feet. The solid mass of Earth itself moves somewhere between 8 and 12 inches. Now, that's not huge, but if an earthquake's right on the edge of happening, even though the tidal forces are only 1/2000th of the torque found in crustal rock, it can certainly be enough to supply that last final straw. So, you know, the straw that broke the camel's back, because studies show that statistically there are more earthquakes at the time of great tidal stresses, like now, like today and tomorrow, than should be expected by chance.
Yeah, and I think what's disappointed me most from the scientific community when this has been raised in just the last few decades really is the immediate reaction is, no, don't be silly, you're being conspiracy theorists. But, you know, now there is more and more evidence and, as you say, statistics which are actually supporting this. So our thoughts go out to those folks down in New Zealand. I've got some people down there myself. Now, Bob, the other last question I've got for you tonight is there any proof that full moons affect human behavior? Could they have had any vote on the USA elections last week?
The USA elections, I doubt it, because we weren't even in any particular phase or tidal position last Tuesday. However, studies looking at crime rates, birth rates, mental health, for example, calls to crisis centers, calls, admissions to mental hospitals, this kind of thing, have been done for decades now, and the results have generally been negative. I can't say that there haven't been some interesting positive results. For example, a pair of doctors, a father and son, manager in the 1950s, found an increase in births, not for the full moon, but for the period, the half-month period when the moon was full. Now that's when the tides are greater. Surveys of mental hospital calls to crisis centers, admissions to mental hospitals, those have been more all over the place. And so you'd have to say, if you looked at this honestly, you can't firmly link the moon to most human behaviors. You certainly can link it to animal behaviors, because there's an awful lot of creatures that follow the tides, especially in the intertidal zones where the tides really go in and out and expose great areas of saltwater marshes, and their predators like gulls that very much live and respond and breed in tune with the tidal rhythms of Earth, including the bi-weekly tidal rhythm of the spring tides versus the neap tides.
All right. Now, we're running a little bit short of time here, Bob, but one thing we haven't mentioned, and it's very appropriate to discuss after you've talked about animal behavior around these full tides. They're not really reacting, are they, to, I mean, turtles, they're not reacting to the tide being full, they're reacting to the increased brightness, aren't they, of a full moon. And this mega moon is even brighter than most full moons, isn't it?
Absolutely right, because even though the moon is only 7% larger than average, nonetheless, it has a greater area. Area, as you know, varies. We remember from high school math that you're talking about pi r squared for the area of a circle, and or 2 pi r. In other words, it's not just a linear relationship, it's much greater than that. So there's more moon area, and then a stronger sunlight is hitting the moon right now, because the moon being closer to Earth also affects that intensity, and that varies inversely with the square of distance. So that produces, so even though there's only a small 7% boost in diameter of the moon tonight compared with average, or a 14% boost between the smallest versus largest moons, it's more like a 30% boost in its brightness and in its tidal effect. So these are real effects.
And we can see it in this comparison image. Once again, these are images previously that we've taken, SLU members have taken with the telescopes, of a micro moon when the moon is very far away from Earth, and then one of these super moons as well. And we can see just, exactly what you were saying there, Bob. The increased area is really quite massive. By the way, as far as human behavior is concerned, we did do a survey this year we've been covering full moons every single month this year. And we did a survey of SLU staff. And apparently, the day after full moons, we're always a little bit more tired than we are on a normal day. And I'm not sure whether that has to do with the fact that we've stayed up broadcasting until the early hours of the morning, maybe.
I'd suspect that has something to do with it. But around here, the tides are going to be amazing on Monday and especially on Tuesday. The tides usually take 1 day to respond to the moon. So the maximum lunar effect, the moon will be closest between 6 and 6:30 Eastern time. In other words, the wee hours of the night, people in the United States will actually see the moon still in the sky as it reaches its closest point. And then the strongest tidal effect will be 1 day after that. So it's still to come. We still have it in front of us.
Bob, thank you so much for joining us tonight. Now, your talk tonight that you're giving, your presentation tonight, are there any seats left there if people want to come along to that?
Yeah, right now there's plenty of seats, but if we tune in again, because this is 9 o'clock Eastern time, the starting time, but it would be interesting to peek in again at, let's say, 9 o'clock or 5 after 9, and there won't be an empty seat.
Okay, well, we wish you well for your live event there. Thank you so much for joining us here for our live event, Bob. It's always a pleasure.
Thank you, Paul.